Okay, so now we want to calculate the area exactly using limits. We talked earlier about how if we let the number of partitions go to infinity, that is, if we let n get larger and larger, their error will get smaller and smaller. And now, we'll do the same problem. We have that f of x is x squared, and we want the area from 1 to 5. Now, let's see how we partition from 1 to 5. Suppose I told you delta x was a quarter. So shouldn't the next partition be 1 plus delta x? And the next one should be 1 plus 2 delta x's, and then 1 plus 3 delta x's, and then 1 plus 4 delta x's, etc. That is, we have A, because we're going from A to B, which is 5. So then we have 1 plus delta x, and A plus delta x, and A plus 2 delta x's, and A plus 3 delta x's, and A plus 4 delta x's, etc. And to find the heights, we find f of these numbers. That will give us the heights. That gives us the heights. Eventually f of 5. That is f for d. That gives us the heights. And the bases are delta x's. Okay, so using that, let us get our formula. We're going to do f of a plus I times delta x. That would be the height times the base. And now we're going to sum this up. And it doesn't matter if you start at 0 or 1. In other words, it doesn't matter if you're doing inscribed, which means you start at 1, or if you do the upper sum. And you start at, so if you're starting at 1, you're adding no delta x's. That's if you're doing lower triangle, lower rectangles. If you're doing upper rectangles, you're going to start at a plus 1 delta x. That is, I would start at 1. Doesn't even matter. With the rectangles, the bases, we're getting so many rectangles that whether we add the first one or not, whether we add the last one or not, won't even matter. It won't even matter. And then we take the limit as delta x goes to 0. Now, I'm going to modify that formula ever so slightly, and then we're going to have our formula. I'm just going to rewrite delta x. Because if I'm not mistaken right now, oh, I do have a typo up here. I meant to say the number of rectangles, I'll mark it down first, the number of, oh, actually what I wrote was okay, but I want to say that the number of rectangles goes to infinity. But right now, I go from 0 or 1 to n. Right now, there's no n's. How can I take the limit and n goes to infinity? Well, I guess there's an n there. But remember, delta x is the length of the interval, b minus a. The interval is going from a to b is b minus a over n. So we're going to use the limit as n. So let me just go up to the top one and change it. Instead of delta x, I put b minus a over n. I put b minus a over n. Instead of case, we're finding the area from 1 to 5. So it's 5 minus 1 over n, or 4 over n. The number of rectangles is n. Okay, so that's what we're going to use. Because the limit is n goes to infinity of f of a is 1. 1 plus I times b minus a over n, which is 4 over n. I times 4 over n times delta x, 4 over n. That's the formula that we're using. Now remember, f of x is x squared. So whatever I'm taking f of, it gets squared. The limit as n goes to infinity of this squared, which is 1 plus 8i over n plus 16i squared over n squared. And this gets multiplied by 4 over n. Oh yeah, I failed to write the summation down. Okay, it's the summation of what's in the big brackets. The limit as n goes to infinity of the summation, I goes from 0 to infinity of, now I multiply what's in the brackets by 4 over n. In fact, I can even factor out the 4. This 4 is now in front, so there's only a 1 here. 1 times 1 over n, 1 over n, plus this times 1 over n is 8i over n squared, plus 16i squared over n cubed. Okay. So we have this last line. I'm going to erase stuff on the top. And now we're going to find this summation. We'll rewrite it so we can more easily find the summation. It's the limit as n goes to infinity of 4 times the summation of 1 over n plus, now only I is changing, but 8 over n squared is a constant. 8 over n squared times the summation of I plus the 16 over n cubed is a constant, but then we have the summation of I squared as I goes from 1 to n. So this is equal to the limit as n tends to infinity of 4 times. As I goes from 1 to n, that's a constant. So that constant gets multiplied by n. The summation as I goes from 0 to n of a constant is c times n. If that constant happens to be 1 over n, then we should get 1 over n times n, which of course is 1, plus 8 over n squared times the summation of I, which is n times n plus 1 over 2, plus the constant times the summation of I squared, which is n times n plus 1 times 2n plus 1 over 6. Okay. So let's clean this up a little bit and move along. The limit as n goes to infinity of 4 times, well this is 1 plus 2 goes in the 8 4 times. So it's 4n times n is 4n squared plus 4n times 1, which is plus 4n, and this is all over n squared, plus. Now, 2 goes into both of these 8 times and 3 times. multiplication on the side. Let's just do this multiplication. N times n plus 1 times 2n plus 1. Well, let's do this first. N times that, so it's n times 2n, 2n squared, plus n, plus 2 more n, that's 3n, plus 1. Times by n in front, you get 2n cubed, plus 3n squared, plus n. But remember, you also have, so I just calculated this. You still have 8 over 3n cubed. You still have that. So you have 8 over 3 times this over n cubed. Over n cubed. Okay. Lots and lots of rooms to make mistakes on these. You have the limit of a product. The limit of 4 is just 4 times the limit of the rest. The limit of 1 plus 4n squared plus 4n over n squared plus 8 over 3 times this mess. So it's 4 times. The limit of 1 is 1 plus the limit of this. Since the numerator and denominator are both n squares, we divide the highest powers are n squared, we divide by the numbers in front. 4 over 1, the 1's understood, 4 over 1 is 4. Plus the limit of this times this. The limit of the first, which is 1/3, times the limit of this. Since the highest powers are 3, we divide the numbers in front. 2 over 1 is 2. So I claim we get 4 times 1 plus 4 is 5 plus 16/3. And 5 and 6 plus 16/3 is 5 and 16/3. And I'm going to have to go to the top to finish off. Let me write this down. We have 4 times 5 and 16/3. What is 5 and 16/3? 3 times 5 is 15 plus 16 is 31/3. And 4 times 31, well 4 times 30 is 120 plus 4 is 124 over 3. That's the exact area under the curve y equals x cubed from 1 to 5. Plus it'll be square units. Okay. If this was 1 inch and a 2nd inch and a 3rd inch, scales off, sorry, all the way up to 5 inches, and inches were up and down, you would be able to put 25, excuse me, this is exactly 41, 1 1/3 squares. Okay, you can put 41 1/3 squares. Now, of course, at the top, you won't be able to put squares. But if you only used up that portion of the square, I left a little bit out on the top. Let me make that bigger. If you only use this portion, well then you can use that area later on to fill in another piece. Times 41 1/3 square inches will fit in there. Square units. Okay, let us try another one. Suppose this time we have that f of x is equal to the square root of x. And the square root of x goes this way. And we want to go from 2 to 10. We want to find out exactly what this area equals. Exactly. Exactly. How much is that area? Okay. So f of x is square root of x, and our interval is from 2 to 10. So the formula is the limit as n goes to infinity of the summation as I goes from 0 to n of f of a plus I delta x. Well, delta x is going to be b minus a, 10 minus 2 over n, or 8 over n. It's going to be I delta x times the base. This is the height, that's the base. And a is 2. And b, you don't need it, but b is 10. So this is equal to the limit as n goes to infinity of the summation as I goes from 0 to infinity of f of a is 2. So it's 2 plus I times delta x, which is 8 over n. That's that delta x times delta x. 8 over n. So this is equal to the limit as n goes to infinity of the summation as I goes from 0 to n of square root of that. Because that's what f does. The square root of 2 plus 8i over n times 8 over n. Okay, and I'm not so convinced I know how to deal with our square roots. Okay, I'm going to change the problem. I'm going to change the problem to x cubed. It's x cubed. Instead of square root, it's cubed. So, it's going to be this cubed. Now if you remember, a plus b cubed. That's a and that's b. This gives you a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay? So this is equal to the limit as n goes to infinity of the summation rid of this. summation as I goes from 0 to infinity, you get a cubed plus 3 times a squared times b plus 3 times a times b squared plus b cubed. That's just this times 8 over n times 8 over n. Okay, so this is equal to the limit as n goes to infinity of the summation as I goes from 0 to n. 2 cubed is 8 plus 2 squared is 4 times 3 is 12 times 8 is 96i over n plus 3 times 2 is 6 and 8 squared is 64. This is 384, 24, 384, 384 times I squared over n squared. The I, the 8, and the n all get squared, plus 8 cubed. 64 times 8 is 512, I think. 512. I cubed over n cubed. And all of this gets multiplied by 8 over n. Okay. Get rid of everything but the last line, and we're going to multiply everything inside the big brackets by 8 over n. Okay, so this is equal to the limit as n goes to infinity, and just like the 4 before, I'm going to factor out the 8 and go in front of the summation, the constant. 8 times the summation that I goes from 0 to infinity. For the record, you could have brought the 8 in front of the limit. And 8 times 1 over n is 8 over n plus. See, now I don't have to multiply 96 by 8. 96i over n times 1 over n is 96i over n squared plus 384 I squared over n cubed plus 512i cubed over n to the 4th. And now I pretty much take the first summation, I calculate the summation. N goes to infinity of 8 times the summation of this. 8 over n is a constant. It has nothing to do with I. Times n. Plus the summation of this. The 96 over n squared goes in front of the summation times the summation of I, which is n times n plus 1 over 2, plus the summation of this. This 384 over n cubed is a constant, times the summation of I squared, which is n times n plus 1 times 2n plus 1 over 6, plus the 512 over n to the 4th times the I cubed, which is n squared times n plus 1 squared over 4. Okay, let me get rid of the last one. So this is equal to the limit as n goes to infinity of 8 times, this is just 8, plus 2 into 96 goes 48 times, so you have 48n squared plus 48n. Think of this as 48n times n, 48n squared, plus 48n times 1. and this is all over n squared, plus. Let's look at 384 over 6. 6 goes into 38 6 times. That used up 36. So there's 2 left over. And 6 into 24 goes 4 times. So yes, it does. 6 goes into 384 64 times. So now you have 64 times n plus 1 times 2n plus 1 over n cubed. Now, if you're clever, remember n is going to infinity. So the term, and we do have n cubed on the bottom. So anything on top that's below an n cubed is going to go to 0. You have 64 times n times 2n. That's going to give you the n cubed. There's no n to the 4th. There's only the highest power is n cubed. That gives you 128. 64 times 2 is 128. N cubed plus lower terms. That means n squares and n's and constants. But it really doesn't matter. Because if n goes to infinity, this is going to go to 128. So you don't have to keep multiplying that out. And now 4 into 512, well, 4 into 512 goes at 128 times. So 4 goes in there 128 times. Now, let us try to play the same game here. You have 128 times n squared times n plus 1 squared over n to the 4th. Well, first, maybe I would say, well, this n squared kills off 2 factors of n's in the bottom, so it's irrelevant. That is 128 times n plus 1 squared over n squared. Well, when you square n plus 1, you're going to get n squared plus lower terms over n squared. Let me write that down over here. You're going to get 128 times n squared plus lower terms over n squared. And when you distribute, you get 128 n squared plus 128 times lower terms, which is lower terms, over n squared. And then it goes to infinity, that's going to go to 128. So you have plus let me just see what happened. Okay. Oh, okay. So coincidentally, we get 128 again. N squared plus lower terms over n squared. Okay, maybe we need 1 or 2 more lines. So we have a product. We have the limit of a product. The limit of 8 times what's in the brackets. Well, the limit of 8 limits distribute over multiplication. The limit of 8 is 8 times the limit of what's inside the brackets. But the brackets are sums and differences. So we take the limits one by one. The limit of 8 is 8 plus the limit of this is 48 plus the degrees on top and the bottom are the same. 48 over 1 is 48 plus the limit of this is also 128 because the degree of the top and the bottom are both 3. Divide the coefficients, get 128. Same thing here, 128. And we get 8 times This here is 56, 128, 128, and 56. This is 290, 320 is it? 322, 22, 12, 22, 312, 312. Get 312. You get 8 times 312, which is 2496. And I think we were integrating from 2 to 10 of x cubed dx. So I'm going to do what's a shorthand method to find the correct answer. Make sure we didn't make any mistakes. Okay, so we get 10 to the 4th minus 2 to the 4th. 10 to the 4th is that number minus 16 over 4. Well, 10,000, that's 2,500 minus 4 is 2496. Yeah, that's the answer. No silly error. Go over these. They're long, they're tedious, but they're doable. Okay, have fun.